let's look at some further applications of the normal distribution. We've already seen a few where we looked at the 68, 95, 97 rule. Let's look and see how we can do this for any type of application, any data set that is normally distributed. So example 1. Assume that adults have IQ scores that are normally distributed with a mean of 100, standard deviation of 15. Find the probability that a randomly selected adult has an IQ between 110 and 120. As usual, we're going to start by sketching a normal curve and labeling it. Okay, once we have it labeled, we have a few options. I'm going to show you just one example where we use the table, kind of going old school, and then we will turn to the technology and do the remainder of the problems using technology. So if we're going to use the table, we have to first convert these values to a standard normal curve using the z-score formula, x minus mu over sigma. And then I'll show you again using the normal CDF feature on the calculator. Okay, so we use the z-score formula. We find the corresponding z-scores. So the one for 110 is 0.67, and the one for 120 is 1.33. Now we're going to look these up. Again, these are my z values. I'm going to look those up in the table. So we're going to look at 1.33, and there's our value, 0.40824. And then look up 0.67 is at 0.24857. So really what we're doing here is we are subtracting those out. The 0.40, I've rounded a little bit here, 0.4082 minus 0.2486, and we get about 0.16, about 16% of the values fall within that range. When we use the calculator, we're going to get a slightly different result just due to some rounding. So again, we're going to go to the norm CDF, put in your lower, your upper, 110 and 120, and then the mean of 100, standard deviation of 15. Select paste and then enter, and you'll get about 16% again. We're off a little bit, right? This is 0.1596, 0.1628, 0.16128. Again, this is okay. This is very usual in statistics. If you have the older model calculator, we get exactly the same answer. Example 2. The lengths of human pregnancies are normally distributed with a mean of 266 and a standard deviation of 16. Part A and Part B. So Part A, draw and shade the normal curve with the parameters labeled. And then Part B, find the probability that a randomly selected human pregnancy is less than 245 days. So Part A. Again, if you haven't done this yet, go ahead and pause the video and see if you can work ahead of me. Okay, welcome back. I'm going to go ahead and draw this out. Does not have to be perfect. 266. Standard deviation of 16. And for now, that's all we're going to do. If you want to, you can put the other values on there. But we're no longer limiting ourselves to values that hit right on a integer value for a z. So for Part B, it says find the probability that a randomly selected human pregnancy is less than 245 days. So this is where I'm going to put 245. Just somewhere to the left of 266. I'm going to go and shade it. Don't have to spend a lot of time getting that exactly proportionate. We're going to put this relative to the 266. It's to the left of 266. Because I know my answer here has to be less than 0.5. So if I happen to mess up and go the other direction, I'll know that something is wrong. I'm trying to find this area here. And I'm going to do this using technology. Okay, so I'm going to do norm CDF. So second var to access the distribution key. Select number 2, norm CDF. Lower bound is going to be negative infinity. I put it as a -1 E99. There are other ways you can put that in. That's the way I've done it. And then the upper is 245. The mean is 266. Standard deviation of 16. And then press paste. So we get 0.095.